Good morning. So today we're going to talk about the asymptotes and wholes of a rational function when it's not in HK form. So before, when it was in HK form, we knew that we could just look at H and K to see what our vertex would be. Here, it's not as clear and there's a few rules. So maybe put this on your half sheet cheat sheet before the Unit 4 test. There's two kinds of breaks that we'll have. First, we'll have a break in continuity, or we'll have a horizontal asymptote, or sometimes we'll have both. So it all depends on these rules that we're going to establish. So if we have removable discontinuity, it's when the factor x minus h, right, because that comes from a over x minus h plus k. When x minus h, oh, that's better. When x minus h can be removed, which means it can be canceled out, then there is a hole at x equals h. So if we can factor out this x minus h, then we know that the hole in the graph will be when x equals h. Now, non-removable discontinuity means you cannot factor the x minus h out of the denominator. So if the factor x minus h is still in the denominator, then x equals h is the vertical asymptote. So if you can take out the expression x minus h, whatever h may be, then you'll have a hole in your graph at x equals h. If you can't, then x equals h will be the vertical asymptote. Now, horizontal asymptotes, which is we're looking at our k value or our y. To determine which one you're going to have, you're going to compare the degrees of the numerator and denominator. So if the degree of the numerator is greater than, remember inequalities, the alligator eats the bigger one. Degree of the numerator is greater than the degree of the denominator, then there is no asymptote. It's just not there. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. So then it'll never cross the x-axis because y is always at 0. So it'll run this way, horizontally. If the degree of the numerator equals the degree of the denominator, then we'll have y, or horizontal asymptote. Here, I'll write that. Our horizontal asymptote will be y equals a over b, where a is the leading coefficient of the numerator, and B is the leading coefficient of the denominator. So you're going to take, remember way back in Unit 2 when you should have been listening to me when I talked about leading coefficients, it's that first term of a polynomial when it is in standard form. So here, our leading coefficient, because it's in standard form, it's in descending order of exponents. When we look at our first term of our highest degree, here our leading coefficient is 1. Here our leading coefficient is 2. Here our leading coefficient is 2. And here the leading coefficient is 2. Now, and here it would be 1. So when there is the same number of degrees in the numerator as the denominator, when they're equal, your asymptote, you'll have to figure out the leading coefficient of the numerator and divide it by that leading coefficient of the denominator. And that's wherever your horizontal asymptote will lie. So, going to number 1, we see that our exponent here, first of all, we know that there's no discontinuity, and that's 0, period. We know that there's no removable discontinuity. So first we have to find if there's removable or non-removable. We say that it is non-removable because when we factor the bottom, we're not going to be able to get rid of x minus h because we can't, there's no x minus h up here. It's just 4. So we know that even if we did factor this, we would just have 4 over x plus 5 minus 2. Don't ask me how I factored. You know how to factor from 2 units ago. So we know that we can't get rid of x minus 2 or x plus 5 because all we have up there is 4. So we're going to say that it is non-removable discontinuity. Big college words. And then we're going to find if we have a vertical asymptote or a horizontal asymptote or both. So when we have non-removable discontinuity, then we know that we do have a vertical asymptote, which is x equals h. So here we have 2 terms. We have x minus h here and x minus h here. So we're going to have 2 vertical asymptotes. So we'll say our vertical asymptote is at x equals, in order for this expression to equal 0, x would have to equal positive 2. And for this expression to equal 0, or to find what h truly is, we know that the h is negative 5. So you can do one of 2 things. You can set these expressions to 0 to find the asymptote, or you can look at the h value and see if the sign is the same as this sign or if it has changed. So we know that the vertical asymptote is at 2 and -5. We need to check the horizontal asymptote. If the degrees are greater than, less than, or equal to. So we know that here at 4, there is no asymptote. There is no degree, because remember, our degree is the highest exponent of a variable. Here we don't have a variable. So our degree, right, if there was an x here, our degree was 0, because you don't see x. It's just 1. Remember, anything to the power of 0 is just 1. So all we're seeing is that 4. We don't see any x. So we know that that would have been 0. And here our degree is 2. So when we look at our table, we see that when the degree of the numerator is less than the degree of the denominator, which is happening here, we have 0 in the numerator, 2 in the denominator, then our horizontal asymptote will be y equals 0. Say our horizontal asymptote is y equals 0. I'm already shortening words and doing abbreviations. You can write it down however helps you remember. They're your notes that you're going to be looking back at. So if you need to write it all out, please feel free to. If you like to abbreviate the way I do, that's fine too. Now, number 2, non-removable or removable. Let's factor it out. So here we'll have x's. I know that the factors of -12 need to get me -1. So I will say -12 and +1. Is that right? No, it's not. I will say, 4 and 3. Duh. -4, +3 will get me -1. Okay. Then I'm going to take out the GCF, which is 2 and x. So 2x, take that out. That will give me x minus 4. So now I can take out x minus 4 and x minus 4. I'm left with x plus 3 over 2x. So here I do have removable discontinuity. So I'll say I have removable discontinuity. So instead of having a vertical asymptote, when I have removable discontinuity, I will have a hole in my graph. So I'll say hole at x equals my x minus h was x minus 4. So my h value was 4. Remember, because it should be x equals h. So, my hole is at x equals 4, and now I have to see if I have a horizontal asymptote or not. I see that my degree in the numerator is 2, but so is my denominator. So I'm going to look to degree of numerator equals degree of denominator. And in order to find my horizontal asymptote, I will have to divide a over b. So a is the leading coefficient of the numerator. When I look at my numerator, I see my leading coefficient is 1. So I'll say horizontal asymptote at y equals 1 over the leading coefficient of the denominator, which is 2. So I have y equals 1/2. And that is my horizontal asymptote. Moving on to my third example, I will factor the top, which will give me 2x and x. And then if I want -1, okay, I'll have -5. And I'll add 2, so that when I multiply those, it'll be 2x times 2, which will be 4x, and -5 times x, which is -5x, -5x, and +4x will give me that -x. And then down here, you can't factor that, so I just have 2x minus 5. Hey, look at that. I have removable discontinuity. So now I'll say removable discontinuity, which gives me a whole at x equals 5/2. Because if I set this 2x minus 5 to 0, I'll end up with 5/2. I would add 5 to both sides and then divide by 2 to get x by itself. So my whole is at x equals 5/2. And my degree of my numerator is 2. My degree of my denominator is 1. So when the degree of the numerator is greater than the degree of the denominator, there is no asymptote. So then I would write no asymptote. So this is how you find whether you have a break, a vertical, being a whole or a vertical asymptote, or what kind of horizontal asymptote you have. Now they're asking you to find or to write a rational function based on the following requirements. So number 4 says it has removable discontinuity at x equals -4. So when we look at removable discontinuity, it says that if we have this, then it will be a whole at x equals h. So that means if x equals h, then h equals -4. And when we write out the expression, it'll be x plus 4. So you can write this however you want. You can put x plus 4 over x plus 4. You still need something left. It can't be 1. So maybe you say times x minus 5, or add a 2 in here. You can add anything else you want, even leave that alone or leave this alone, as long as you'd be able to remove x plus 4. Now, if we say write a rational expression with a non-removable discontinuity at x equals 8, then I know my non-removable means that I'll have a vertical asymptote at x equals h. So if x equals h, then h equals 8, And the expression I'm looking for in my denominator will be x minus 8. Then it says that I have a horizontal asymptote at y equals 2. What would give me a horizontal asymptote at y equals 2? Here I would have no asymptote. Here my degree or my asymptote would be at 0. So here it has to equal with the leading coefficient of the numerator over the leading coefficient of the denominator to give me a over b. So I'm going to keep x minus 8 if it's just by itself on the bottom, it doesn't really matter if it has parentheses or not. But because it's going to be non-removable, I can't have x minus 8 up here. So I'll say 2x plus 1 because that's just something I came up with. If you had the last part of this, doesn't really matter, but we can even just put 2x. All we know is that with a horizontal asymptote, my degree of the numerator has to equal the degree of the denominator. So my degrees are the same. I both have a degree of 1. And that y equals a over b should be y equals 2. So the only thing I could think of was 2 over 1. It's the easiest. And this leading coefficient would be 2 over this leading coefficient that is 1. Now, our last example, they want us to write a horizontal asymptote with a hole at x equals 3, which means removable discontinuity. A vertical asymptote at x equals -5, which is weird because that means a non-removable discontinuity, and a horizontal asymptote at y equals 0. So that means that the degree of the numerator should be less than the degree of the denominator. So we have a removable discontinuity in the denominator and a non-removable discontinuity. So all that means is that the removable one we'll write first, right? It's all in the denominator. Removable, x equals h equals 3. So down here, I'll have x minus 3. For the non-removable, x equals h equals -5. So I'll have x plus 5. Now this one, I will remove, so I'll put the same one up here. And now my last requirement is that the degree of the numerator is less than the degree of the denominator. So here I'll only have one x, and here I'll have two x's. So I know my degree on the bottom is 2, and the degree of my numerator is 1. So this checks out. So I can leave it like this. I don't have to add anything else. And we'll have, when we remove these, a whole at 3. This will be left under 1, so it'll be my non-removable, and I'll have a vertical asymptote at -5. And because of my degree, I'll have my horizontal asymptote at y equals 0. So everything checks out. Definitely write these rules on your half sheet cheat sheet. If you're prepared and you're smart, you might be already working on this to put it in the half sheet. As you take your notes, put it aside, make a note, something that you need this. Yeah. If you have any questions, go ahead and email me, message me on Canvas, whatever you need. And you can also always ask your current set. All right. Have a good day.